Welcome to another one of my SAT mathematics videos. In this video, we're going to look at sequences and probability. So this is the second last video of the series, and then I guess you just need to revise. And so anyway, let's talk. When we look at sequences, the first thing we need to look at is arithmetic sequences. So these are all arithmetic sequences. Try and see if you can find something similar, right, between all of these. Pause the video, think about it. Now I'm going to tell you what's similar about them is that they all have a common difference. Let's go back. Here 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is also 2. They have a common difference of 2 between terms. Similarly here they have a common difference of 4 between terms. Similarly here 116 minus 100, 16, 100 minus 84, 16, 84 minus 68, 16, 68 minus 52, 16. They have a common difference, and that is what defines an arithmetic sequence. If they have a common difference, it is an arithmetic sequence. So this is also an arithmetic sequence. Each arithmetic sequence has two important numbers. The first is A, which is the first term of the arithmetic sequence, and the second is D, which is the common difference. Here it's 4. Using these two, we can calculate we can find the value of any other term. The n term is given by the formula A plus n minus 1 into D. So if we had to find the 15 term for this sequence, 11, 8, 20, 18, 25, we first find A, which is 11, the first term. We find D, which is 7. And the 15 term will be A plus n, which is 15 here, 15 minus 1, D, which is 7. That's 11 in plus 14 into 7, that is 109. And if we start writing down the numbers in order, we'll see that the 15 term is 109, just as the formula gives us. Sometimes this is one of the more challenging questions you can get in the SAT. And arithmetic sequence's 4th term is 11 and 9th term is minus 14. Find the sum of the first term and the common difference. So the first thing you want to do is we know that A plus 3D, which is the 4th term, is 11 and A plus 8D is minus 14. Once we write this down, something we'll notice is we have a simultaneous equation over here. Now the coefficient for A is both 1, they are similar, so we just subtract both the expressions with each other. A minus A is 0, 3 minus 8D is minus 5D, 11 minus negative 14 is 25, so D is negative 5, right? We substitute D is equal to negative 5 in one of these equations. A plus 3 into negative 5 is 11. Therefore, A is equal to 26. It's just normal simultaneous equation procedure. And then we just wanted to find the sum of the common difference, which is negative 5, and first term, which is 26. That is 21, and the question is solved. The second type of sequence you get is geometric sequences. These are geometric sequences. Once again, try and see if there is something similar. What you will notice is all of them have a common ratio. So what I mean is 32 divided by 6 is 2, 16 is 2, 16 divided by 2 is A, divided by 8 is 2, 8 by 4 is 2, 4 by 2 is also 2, 1 by 3 is 1 by 3, 3 by 9 is also 1 by 3, 9 by 27 is also 1 by 3, and 27 by 81 is also 1 by 3. So all I have to do to find the next term is multiply by 1 by 3. Here 1 by minus 1 is minus 1, minus 1 by 1 is minus 1, 1 by minus 1 is minus 1, and minus 1 by 1 is minus 1. So all you have to do to find the next term is multiply by minus 1. They're all geometric sequences because all of them have a common ratio, and that's what defines a geometric sequence. Each geometric sequence is defined by its has two important numbers: its first term, 81 over here, and the common ratio, which is 1 by 3 over here. 27 by 81 is 1 by 3. The n term can be found by A multiplied by R into n minus 1. Remember, the A is just multiplying with R n minus 1. It is not n minus 1. It is not A R raised to n minus 1. It is A multiplied by R into raised to n minus 1, right? So find the 11th term for this sequence, 32, 48, 72. So the first thing you want to mark out is the first term, that's 32. The second thing you want to mark out is the R value. So 72 by 48 is 1.5, 48 by 32 is 1.5. Now we have that. We can do A into R n minus 1 to find the 11th term. A into R n minus 1, 11 minus 1, 10. And therefore you could use a calculator and you will get 1845.3. I've rounded the answer off. So one of the more challenging questions you can get for this is they might say something like a disease has 112 carriers initially, and each week the number of carriers increased by 10%. So what is the number of carriers of the disease after n years, right? So one thing you want to check is here they've given you A very clearly in this word problem. It is 112. So you're going to remove any option that does not have 112 as A. All of them do have that, so we move on to the next hint. Now they say the number of carriers are increasing by 10%. Now you might be tempted to think that the common ratio is 0.1 because it's 10%. But as we did in percentages, an increase means that each week, in the next week, there will be 100% plus 10% of the number of carriers, which means 110%. Therefore, the common ratio is 1.1. Therefore, we remove anything that does not have a common ratio of 1.1. The next thing we want to know is, now that we are left with two options, is n is given in years, right? This means there are 52. This means but there are 52 weeks per year. The rest of it, this 1.1 is the ratio it is increasing by each week, right? And but n is in years. So one thing is, so we know that there are 52 weeks in a year. That means it is increasing 52 times each year. Therefore, if it was after 2 years, it would have increased 104 times, right? And therefore to find the number of weeks that are in n years, we need to multiply 52 into n, which is 52n. Therefore 1.1 needs to be raised to 52n, and that is the correct answer. Now the next thing we want to look at is repeating sequences. So these are things that repeat after a set number. So 2, 4, 8, 16, it goes back to 2, and similarly over here. So here the key thing is identifying what the first term is, and once again identifying after how many numbers does it repeat itself. Here it's 5 because it comes back to 81 after 5 terms. So if we have to find the 11 term for the sequence, what we need to do is divide 11 by 5 and calculate the remainder. The remainder is 1, and therefore it is the same as the first term of the sequence, which is 81. For the 12th term, the remainder would have been 2, and therefore it would be the same as the second term of the sequence, which is 27, right? And so on. Probability. Now, the thing I want to clarify here, it's most of the probability in the SAT is basic, but there is a difference between and OR events. In and events, you multiply probabilities. In OR event, so if I was asking you to get 2 heads in a row, it's an and event, so I would multiply half into half to get the probability 1 by 4. But if it's an OR event, you add probabilities. So something like rolling a dice to get a 2, 3, or a 4. So I'll add the probability of getting a 2 with the probability of getting a 3 with the probability of getting a 4. That is 1/2. So let's take this question. Given that a dart is equally likely to hit any point on the square board, these are the dimensions. Find the probability of scoring a 25 out of 5 on the first throw and scoring a 25 followed by a 10, right? So the first thing you want to, so let's do the first part first, scoring a 25 out of 5 in the first throw. So let's find the probability of scoring a 25. That is the area of the 25 divided by the area of the whole board. So 2 into 2 divided by 12 into 12, that's the answer. The probability of scoring a 5 is this black region divided by the whole board. This black region is the entire board's area minus the area of this square. So that comes out to be 80 divided by the area of the whole board, that is 144. The next thing you want to notice is this is an OR event. So you add these probabilities together. So 80 plus 4 is 84 by 144, and then you just simplify it. Moving on to the second part, you once again find the probability of scoring a 25, and this time it's followed by a 10. So you need to find the probability of scoring a 10. That is the area of this square minus the area of scoring a 25. So that is 8 into 8 minus 2 into 2. So that is 60 by 144. Now this is an AND event. So we multiply these probabilities together, and that gives us a simplified answer of 5 divided by 432. 5 by 432. The last thing you want to look at in probability is sample spaces. These are useful for dice questions. So they might say something like a dice is rolled twice. what is the probability that the sum of the rows is a 2-digit number, right? So in this case, the method you use to do it is draw a sample space. So you have all the potential outcomes of both the die on one on the header of the columns and one on the header for the rows, and then in the sample space you actually write down the results: 1 plus 1 2, 1 plus 2 3, and you do that for all the 36 possible outcomes. Then what you do is you single the ones that are 2-digit numbers, because that is what is asked in the question. Now we count 6 of them. There are 36 possible outcomes, out of which 6 yield 2-digit numbers, and therefore the probability is 1 by 6. This is the easiest way to attempt these dice questions, so always use a sample space if it is a question like this, right? Or they might ask you, what is the probability that the product of the two die things is greater than 10, right? So always use a sample space for that kind of question. In the next video, we're going to cover trigonometry and complex numbers. Complex numbers is probably the hardest or the most advanced concept we do in the SAT, but what is present is pretty easy. You do not really need to know like de Moivre's theorem and things like that. So it's still pretty easy. So do not worry too much. And with that, guys, see you next. Thank you. Have a great day.